In the last video, I was just drawing arrows. I wanted to show you that the antiderivative of lowercase f of x, the antiderivative of that is capital F of x. But in math, you had better believe that we have better symbols than this to show how to go from here to here. And what is this symbol that brings us from a function to its antiderivative? This is the integral sign, this weird long letter S. And this integral sign is the thing that allows us to take a function and find its antiderivative. Let's see how to use it. There's a lot of terms at first, but we'll take our time to make sure we define each one. So let's say you want to find the antiderivative of f of x. You put this integral sign, you put f of x. This is known as our integrand. And let me put in this one as well. This is our integral sign. Then you also need to put this dx next to it. This is, we're taking the antiderivative of f of x with respect to x. So let's write that over here. This is our variable of integration. But all this means is we're taking the antiderivative with respect to x. So if the things match, it shouldn't be any extra work for us. Let me write that. So with respect to x, just in quotation marks. This will equal our antiderivative plus c. So I'm not going to write antiderivative, you've heard me say that enough, but I will write the c because it stands for our constant. And this is something that many students forget. If you didn't get a chance to write that stuff down, I'll encourage you to rewind the video a little bit and write down those definitions. But let's go ahead and use this to see how it works. So let's have our integral sign, and let's take the antiderivative of 3x squared, since we looked at that in the other video. We can't do this right now because the integral sign has no idea how to do this, so you have to point it in the right direction. You have to say, okay, I want you to take the antiderivative of 3x squared with respect to x. And in this way, it understands the antiderivative is x cubed. It came from x cubed. And then plus rc. This one's pretty easy, but how does it work when they get harder? You don't just want to be guessing all the time, and so you want to make sure you're using the reverse power rule. So just like we learned the power rule for derivatives, we're using the reverse power rule for antiderivatives. In general, the rule works like this. If you want to find the antiderivative of some x with a power of n, that's just some number, a whole number, integer, fraction, whatever it is, x to the n power, with respect to x, then the antiderivative is x to the n plus 1 over n plus 1 plus c. And I want to write this really big because, seriously, everyone's going to forget this plus c. Let's try one out. Let's say we want to take the antiderivative of x to the 5th with respect to x. Well, the antiderivative is x to the 5 plus 1 over 5 plus 1. Like I said down here, if it's x to the n, here we have x to the 5th, x to the n plus 1, x to the 5 plus 1, over n plus 1, 5 plus 1, plus c. And we can simplify this a little bit, of course, to get x to the 6th over 6 plus c. Let's look at another one. Let's try x to the 7th with respect to x. And if you think you already know what to do, go ahead and stop this video and try it for yourself. When you take the antiderivative of x to the 7th with respect to x, you get x to the 7 plus 1 over 7 plus 1 plus c. And we need that c because there's a constant that we're just not quite sure about. We talked about in the last video. So you get x to the 8th over 8 plus c. These get a little bit harder, but the reverse power rule always stays the same. So if you can remember the rule, you can figure out the harder ones too. Let's say you want to take the antiderivative of x to the negative 5th with respect to x. Well, you do x to the n plus 1, or x to the negative 5 plus 1, over negative 5 plus 1 plus c. Simplify this to x to the negative 4 over negative 4 plus c, and this would be your antiderivative. If you want to simplify this even further, you can. You'd change this to negative 1/4 x to the negative 4 plus c, which simplifies more to negative 1 over 4 x to the 4th plus c. However, I went ahead and checked, and Khan Academy will accept this. This is just more simplification in case you needed to. How about the antiderivative of x to the negative 3 dx? Go ahead and pause the video now and see if you can figure this out on your own. Well, it's x to the negative 3 plus 1 over negative 3 plus 1 plus our constant of integration. And we'll just simplify this one step to x to the negative 2 over negative 2, and always remembering our plus c. And like I said for the last one, we can just leave it like this. There's one more type of problem, and yet it still uses the reverse power rule. So let's think about taking the antiderivative of x to the 1/3 dx with respect to x. Well, it's still going to be the same thing. It's x to the 1/3 plus 1 over 1/3 plus 1, which simplifies to x to the 4/3 over 4/3. And we can simplify this one step further. When you divide by a fraction, you actually just multiply by the reciprocal. So you get 3/4 x to the 4/3 power.